Welcome, everyone. Have you ever wondered how scientists can talk about the distance to the stars without having to write out a number that's like a mile long? Well, today we're going to unlock that secret. We're talking about a super powerful tool called scientific notation. It is the ultimate shortcut for taming those gigantic, crazy numbers.
All right, so here's our game plan for this explainer. First, we'll talk about our learning goals. Then, we'll get into why we even need this stuff. After that, we'll cover the conversion steps, put it into practice, and then it's time for a challenge. We'll wrap up with the solution and a quick recap.
Okay, first up, our learning goals. So by the time we're done here, what will you be able to do? Well, our goal is pretty simple, actually. You're going to understand why we use scientific notation in the first place. You'll be able to define its core parts, convert those big old numbers into scientific notation, and then, most importantly, apply those steps to solve problems. Sound good? Let's get started. So, let's tackle that first question. Why do we even need this? What's the problem with really big numbers anyway? Well, let's look at a real-world example from outer space that shows exactly why this is such a game changer. Okay, just take a look at this monster of a number. That's 5,880 billion. We're talking nearly 6 trillion. And what is it? It's the number of miles a tiny beam of light travels in just 1 year. You've probably heard of it. Scientists call it a light year. It's literally how they measure the massive distances between stars and galaxies. And yeah, that is a lot of zeros to write. I mean, can you imagine trying to type that number into a calculator? Or writing it down over and over again for your homework? It's so easy to miss a zero or just completely lose your place. It's not just annoying, it's basically a recipe for making mistakes. Luckily for us, there's a much simpler way. As the quote here says, scientific notation is just a way for us to write these huge numbers in a shorter, more condensed way. It helps us shrink them down, making them way more manageable and just easier to work with. And here's the core rule, the secret sauce, if you will. Scientific notation always has two parts. First, you got a number that's at least 1, but less than 10. And second, that number is multiplied by 10 raised to some power. So that nearly 6 trillion miles we just saw, bam, it shrinks down to this simple, clean expression right here. Much better, right? Okay, so how do we actually do that? How do we get from that huge, clunky number to the simple, neat one? Well, the process is actually surprisingly easy. Let's break down the 3 simple steps to do it. And we're going to follow these 3 exact steps every single time. It's like a recipe. First, you find the first digit that isn't a 0, and you imagine moving the decimal point right after it. That's your target spot. Step 2, you write down that new decimal number, and you can just drop all those extra zeros at the end. And finally, step 3, you count how many places you had to move the decimal to get there. That count? That's your exponent. Let's see it in action. All right. Theory is great and all, but math is really all about practice, right? So let's see how this actually works with some real numbers. We'll start with something a little smaller just to get our feet wet. Okay, for our first example, let's take the number 6,500. So step 1, find the spot. The first digit is a 6, so our target is right after it. Now, here's a key trick to remember. In any whole number, the decimal point is kind of secretly hiding at the very end. You just don't see it. So our job is to move that invisible decimal point from the end all the way over to between the 6 and the 5.
And now for step 3, we count the jumps. So, starting from the end, we jump 1, 2, 3 places to the left. That little journey gives us our new number, 6.5, and it tells us our exponent is 3. So the final answer is 6.5 times 10 to the third power. See? Simple as that.
All right, you ready to level up? Let's try 19 million. It's a bigger number, but the steps are exactly the same. So first question, where's our spot? Well, the first digit is a 1, so we need to move that decimal from way at the end all the way up to right between the 1 and the 9.
Okay, let's count those jumps together, starting from the end of the number. Here we go. 1, 2, 3, 4, 5, 6, 7. A 7-place jump. So that means our decimal part is 1.9, and our exponent is 7. 1.9 times 10 to the 7th power. I think you're getting the hang of this.
All right, now that you've seen me do it a couple of times, it's your turn to be the expert. I've got a challenge for you to try on your own. Okay, grab a piece of paper. Here is your challenge number 2,750,000.
Your mission, should you choose to accept it, is to convert this number into scientific notation. Just remember those 3 steps we talked about. Find the spot, rewrite the number, and count those jumps.
Go ahead and pause the explainer right here and give it a shot. We'll be waiting for you on the other side with the answer.
All right, welcome back. Pencils down. Are you ready to check your work? Let's look at the solution, and then we'll do a quick recap of everything we've learned. And the correct answer is, drumroll please, 2.75 times 10 to the 6th power. Why? Because that decimal had to jump 6 places to land right between the 2 and the 7. If you got that right, give yourself a pat on the back. That is excellent work.
So let's wrap this up with the key takeaways. What are the most important things to remember? First, scientific notation is all about making huge numbers simple. Second, that format is non-negotiable. It's always a number between 1 and 10 times the power of 10. Third, that little exponent isn't just a random number. It's telling you exactly how many places the decimal moved. And finally, for now, remember that positive exponents mean you're working with a really big number.
And to leave you with something to think about, now that you know how to write these big numbers, how could you use this? Think about comparing the size of planets in our solar system. Instead of counting all those endless zeros in their masses or diameters to figure out if Jupiter is bigger than Saturn, how could scientific notation make that comparison pretty much instant? It's an absolutely powerful tool for understanding the truly massive scale of our universe. You all did great work today.